This conference will now be recorded.
Okay, so good morning, friends, and welcome back to the session that is Big Data Masters program. So far, we have gone through with big data basics, and then we have started Hadoop. Then we have gone through with Hadoop ecosystem and its component, and we have gone through in detail with the functionality of SDFS and MapReduce, and we tried to go through with certain aspects like how we will be able to execute the programs once we are writing them inside the Java. Okay, so from the big data engineer perspective or big data solution architect perspective, it is not mandatory to go through in detail with Java, but certain aspects like how the functionality is being happening in the background, that is the, you can say, important stuff, and at least we must have the understanding about that particular stuff. In that direction, what we have seen, we have executed multiple flavors. And what was those particular flavors like? Once we are having a particular file, and then we are going to split it, then it is given to record reader, and we were having two components for which we need to code like mapper and reducer. So this methodology we have seen practically. Then we tried to reduce it to zero, and we have seen that only mappers are there in the output file, and this is the desired, you can say, state where no reducer is working. But we can't have jobs. It might be possible that we can have certain jobs where reducer is not working, but the jobs which are not having reducer, those are the most performant jobs, huh? And it is recommended that, like, we need to offload reducer, because shuffling is being happening once the data is moving from mapper to reducer. So that is going to add certain latency. Our main focus is to reduce that particular shuffling. Then another aspect what we have seen, like how to like by increasing the reducer to 2, and then what we have identified, like two files were there in the output directory. And at this moment, the partitioner is working onto the system defined logic, like which key is moving to which reducer, that is decided by the partitioner. Okay, we have not defined our customized logic. So based upon the system logic, the keys were moving to a particular reducer because two reducers were defined. And it is the job of partitioner that one key will not be moved to two reducers. So unique key will be moving to a particular reducer. Then what I said, we need to focus in order to minimize the amount of shuffling, and shuffling will be minimized once we are having certain stuff that is able to offload reducer. So we have gone through with combiner aspects, and combiner is minimap, known as minimapper as well, and it is having the benefit of parallelism. It is available at the mapper side. So that is perfectly fine, and we have seen that mappers, this mini mapper or combiner is having reducer logic only, and we need to write down, and we need to, like, uh, keep the things in mind, that data types that we are going to pass inside the combiner, that must be with respect to the reducer input, huh? So those particular things we need to keep in our mind, huh? So this particular approach we have seen, like mapper, combiner, and reducer. Then like we want that the keys will be moved based upon a customized logic. So for that, we have seen like how to write down the customized logic, and that is nothing but in terms of partitioner. So from the developer's perspective, mapper, combiner, partitioner, and reducer. This particular logic they need to write, and then they need to execute it. We have seen the execution based upon this particular Eclipse ID, and over here we are just writing down the code and then executing it. This is good for testing perspective. Like say we are having certain code, and if there are certain changes, and then like we will be able to change it over here. But once the code is tested, okay, we need to proceed for the deployment. And in that particular way, like what we need to do, we need to export this particular code as a jar, and then we will be able to perform the execution. Just have a look how to export this particular code as a jar, and then we need to execute that particular jar, and we will be able to get the same outcome. So that is the stuff that I want to explain. This is the last topic from our first module. Then we will have certain quizzes. Quiz time will be there, and then we will proceed for the next module. Okay, so in order to export the the program that we have written, like it is having main reducer, main reduce map, combiner, and custom partitioner. So these particular classes are there. So in order to export this, just you need to click onto the project that you have created, then right click on it, and you will be able to see export. So export is there, and then runnable jar file, that is fine. Let me click onto the next. And then what you need to do, you need to select the export destination. Like this is the main word count. You need to select the main word count over here inside the launch configuration, and then you need to give the export, you can say, destination. And let me mention, say, best26.jar, bdf best26.jar. Okay, so export required libraries. So over here, like I'm going to extract all the dependencies. Okay, I'm going to extract all the dependencies so that like I will be able to execute this particular code. Now, what I need to do, extract required libraries into the generated jar. Then
Sir,
click
excuse
on.
me. Have you started the recording or not?
The recording has been started. What I think so. Let me check it. So recording is going on.
Okay, okay. Sir.
Okay. So just extract required libraries into the generated jar. Then finish. It will throw error. What has happened? This is new configuration. Just a minute. I need to check over here. Okay, main one. Main one is with respect to our batch 26. So I need to extract because like main is not available over here. Main one is available. So I need to extract with respect to that. The enable jar, that is fine. And new configuration, one word count, main one batch 26. Okay, so this is what I need to have, and I can give any name, say batch 26 over here. And then finish. This is like certain warning, no need to worry about this. So home, cloudera, desktop, bdf and bash26.jar, that will be the jar file. And i I am going to utilize this particular file in order to run the code. So it is taking some time. Export is being happening. It is going to extract all the classes. Say it is at this point of time it is exporting custom partitioner class. So all of the classes will be, you can say, packaged in a jar file, and then I will be able to execute that. So this is the normal way of executing the code. You need to package that particular code that you have written in a jar file. It might be possible that you have written it, you have like developed this particular code and you have given it to the customer. So customer, once you are giving it to the customer, then you need to package all the dependencies, and then the customer will be able to execute this. So export done with warnings, not an issue. Okay, so let me show you this particular jar file, bdf. So inside bdf we are having bash26.jar. So this jar file is there, and what I need to do, I need to do the execution of the code with respect to this particular jar file. So let me open the terminal, and in order to write, basics. Okay, so what I told, running the code on Hadoop. Okay, what I need to do to run the code onto Hadoop, I need to package it. For this, I need to export the project as a jar file, and then do the execution. So what I have done, in order to export, let me repeat it once again. We are having this particular project that we have created, bash26, and onto this particular bash26 I need to click onto the export, then runnable jar. Then you need to choose the configuration, launch configuration. So in our case, main one, bash26, this is the configuration where we have written this particular code. All the files, like main mapper, main map reduce, custom partitioner and custom combiner, these are the classes that we have created for the bash26 project. So I need to export this, I need to launch this particular configuration, and then give a destination path. I can give any name over here, and then click onto the export required libraries into the generated jar, and then click on to the finish. You will be able to have jar file. So jar file is there, and we are able to see it over here. Now in order to do the execution, what you need to do, you just need to type, the syntax is how to execute the exported jar file. So the command, the syntax is Hadoop, then jar, and you need to give the jar name. and then you need to give the input path, and then output path. This will be the syntax, output path. So, uh, Hadoop jar, that is fine. That is the keyword that we need to have. Hadoop jar, that is fine. The jar name. So, jar name is nothing but this particular batch 26, and where this particular batch 26 is available onto this particular path. Let me copy this and paste it over here. So, jar name is batch26.jar. That is perfectly fine. Batch26.jar. Okay. Now, input path. So, previously, once we were executing the code, then we were passing certain arguments. Let me show you arguments. So, these are the arguments that we were passing. This is nothing but the input path where the file is existing, and this is nothing but the output path. And I told it multiple times that output path must not exist. So this is the output path. Let me copy this and paste it over here onto the notepad. So output path, and this is desktop data. And inside desktop data, let me check how many directories has been created. Data. So output 6 is available. Now let me create output 7. So inside output 7, I will be having the output. So let me copy this particular command and paste it onto the terminal. And you will be able to see like whatever the steps were there inside the execution during the execution of Eclipse. Same you will be able to see over here. So input path does not exist. So it is showing like input path is not existing. So what I need to check input path. Hello.txt, home, cloudera, desktop, data hello.txt. This particular file, is it available or not? This is available. Home, cloudera, desktop, hello.txt. Okay, so input path is available. So what is happening over here, friends? It is taking this particular path as an input. Okay, it is taking this particular path as an input. So what I need to do, I need to move this particular file in Hadoop. So let me move it. So SDFS, FS, CP, and let me check. So test one. Let me use test one. What is there inside the test one? User Cloudera test one. So nothing is there in test one. So let me pick up this particular path and paste that or copy that particular file over here. So Hadoop FS Hadoop FS put. So friends, you need to tell me, do I need to use cp command or put command? If you have gone through with the practice, then you might be having the
Sir,
information which
uh, we need to transfer or just copy?
I'm going to copy.
Okay.
So you need to tell me like how I will be able to move this particular file inside HDFS. If you have gone through with the practice, then you must be having the knowledge.
We can, sir, use put also there.
And CP, will it work?
Not, sir.
CP, it will not work. Huh? Akhil, what about you? CP will work or not? Akhil
No, sir.
and Rohit, what about you? Rohit, Rahul, Raj Babu, Kishan, Shivam. CP will work over here or not?
I think no, sir.
Why? Why CP will not work? Shivam, Raj Babu, Rahul. Okay, so friends, what is happening? This CP command, it will work once I'm moving the data within HDFS. Okay, so if I'm onto the HDFS side and I want to move the data within HDFS, like from one directory to another directory, then definitely CP will work. But at this moment, I want to have, I am trying to move a file which is existing onto the local and I'm trying to put it on onto the SDFS. So CP command will not work. That is the thing that we need to keep in our mind. So I'm going to put or copy from local. Both of these two commands will work over here. So let me copy this and paste it over here. So Hadoop FS hyphen put. This is the source path and this is the target path. Huh? Okay, perfect. Let me verify the same as well. So test is not available. Test one is there. Test one. I need to give the complete path. User Cloudera test one. Okay, so batch 26 jar is available over here. Now I need to copy this particular path. Copy, and instead of this local path, I need to change it. I need to change it over here. Hadoop jar. That is perfectly fine. Okay, and I need to give this particular path once again. Sorry. Okay, so let me copy this and paste it onto the terminal once again. Not a valid jar. Once the execution is done, then I will tell you why it was throwing certain error. So map 0%, reduce 0%, map 100%, reduce 0%. It will be 100% soon, and then we will be able to get the outcome. Number of split 1. Okay, then I will say map reduce submitted application. This is the application. Okay, so execution has been done. We are able to get the output, and where we will be able to see the output inside the Hadoop only. Inside the Hadoop only. Let me show. So Hadoop fs-ls and user Cloudera test1. Inside test1 we will be having output 7 as a directory. Okay, so output 7 is there, so why we were getting this particular error? What was the issue? Once we have done the export, then we have placed this particular jar inside uh, inside the local of this particular machine, inside the local of Cloudera. So it was available onto this particular path. That is perfectly fine. Like over here we are having this particular file, and we are taking input from the local itself. We are trying to execute the file which is executing onto the Hadoop, and we are expecting input from the local. So over here it was throwing error once we were mentioning the path from local. This it was throwing error once we were using input from the local. It was throwing error. Then what we have done, we have placed this text file hello.txt inside the Cloudera, you can say inside the SDFS, and we have stored the outcome inside the SDFS itself. So jar location can be anything. So over here I have placed the jar onto the local, and local of this particular machines like home Cloudera, and the output and input file, these are created onto the HDFS side. And because of this particular reason we are getting error over here. We were getting the error input path does not exist. So this is the methodology in order to have the execution of jar files. Sometimes it will happen that you need to add certain jars. Say certain jars are not available inside the Hadoop, inside the HDFS. So what you need to do, you need to add those particular jars. And Hadoop jar, this is the extension or prefix that you need to utilize in order to have the execution of a particular jar. So Hadoop jar, this is the extension. Then you need to give the jar name or the path for that particular jar file. Then what will be the input for this particular jar, and what will be the output of this particular jar. So correct command is this one. Let me repeat it once again. So once we were executing with the help of Eclipse, so that is not the way of working with Java or inside the production environment, because like if you are going to change the system, or if you have utilized, if you have important certain libraries, then if you are going to share this particular code to anyone else, then he will not be able to do the execution. So, Java is platform independent. Huh? Why Java is platform independent? Because like whatever the dependencies it need to have, those particular dependencies will be clubbed together, and we are sharing the file with all the dependencies. That's what is happening over here. Export and then runnable jar, and extract required libraries into the generated jar. So whatever the library that we have utilized over here, say import this Apache Hadoop and all, those particular libraries has been clubbed together, and then a jar file has been prepared. In that particular jar, like if I'm going to pass this particular file to anyone, so he will be able to execute it. There will not be any dependency related issue. So because of this particular reason, like we can say Java is platform independent. So it those particular things has been you can say clubbed together, and clubbed together into a package, and that particular package we are going to pass in terms of jar file. Then in order to have the execution of that particular jar file, what we need to do, we need to just mention Hadoop jar and then jar file name. We need to give the input, and we need to give the output path. Input must be from the SDFS side. Previously, like we were getting the error once we were placing the input from the local of this particular machine, and it was throwing error, input path does not exist. So this is the normal way of working, and this is the last topic as well from the Hadoop side. Just have a look and ask if you are having any doubt. Just have a look. Naresh, Akhil, Rohit, Rahul, Raj Babu, Kishan, Shivam, anything that is.
Hi, sir.
Mm-hmm.
So you are saying work with
Your voice is not clear,
local.
Raj. Your voice is not clear. Can you come closer to
Right?
the mic?
Is it good now?
Yeah, yeah, it's fine now.
I am saying you are saying that we cannot local to SDFS with the help of jar.
Mm-hmm. Come again. Local to SDFS.
You said when you put the input path from the
Mm-hmm.
local, the
Mm-hmm.
output to SDFS, it is not working. And
Yes.
on the you when you put the input path from the SDFS and output is also from the SDFS, so it will work. So
Mm-hmm.
understand that input from local and output from SDFS, it will not work with the help of Eclipse, with the jar execution.
Actually, the thing is that Raz, like once you are doing the execution, I told you just a minute. So what is happening? Just try to focus over here. All of you. Hello. This is replicated to all of you guys. So you are a user, and you are having a Hadoop cluster. Hadoop cluster. So then you are talking with the help of say as node, as node. Okay, so as node, once you will be inside the actual working environment of Hadoop, or like you will be having 10 node, 50 node, or 100 node cluster. So user, developer, client, whatever, he will be sitting over here. Then you will be getting the credentials for as node, your user ID and password, and then you will be interacting onto the Hadoop. Okay, with the Hadoop you will be able to interact. So try to think like why we need to why we need to have Hadoop, because we are having huge amount of the data, and the data need to be processed. And another methodology, like program is moving to data, moving to data location. Okay. So, in the normal way of working, what is being happening? Say you need to fetch certain data. Okay, you need to like you are having 100 GB data, and on 200 GB data you just need to find out the sum of all the digits, like onto the 100 GB data, say certain digits are there, and you need to find out the sum of all the digits which are available into 100 GB data. So what you need to do with respect to the normal flow, you need to move this particular data into your machine. Then you will write down the code, and you will be able to calculate it. Over here, what is being happening? The movement of the data is taking too much time, like from servers, different servers to your machine. And it might be possible your machine is not able to handle that particular data. But over here in the Hadoop world, the program is moving where the data is stored. So data is there inside the SDFS only. Okay, and we are moving our program, and program is nothing but the jar file. In this particular case, program is nothing but the jar file. We are moving the jar file onto the data which is stored inside the SDFS. Okay, so data is available already there, and this particular movement of the program will take small time. So user will interact with edge node, and he will be able to move the code, and the code will be executed onto the data which is stored inside the HDFS. Okay, and then the result will be moved, and that will be less. So this is nothing but put is happening over here, say. And once we are like having the outcome, then get will happen. So inside the Eclipse, Eclipse is available into the local. Okay, Eclipse is available. It is installed in the local of your Cloudera Quick Start VM. This is an application or IDE, and over here we are having multiple jars. We are having multiple jars which we have imported. Okay, it is it is not, you can say, we are not saying like it is fully utilizing the Hadoop cluster. It is not fully utilizing the Hadoop cluster over here. Okay, but yes, like it is running onto the local, and we are able to get the outcome. Okay, and that's why like it is able to pick the input from the local and share the output from the local to the local. Right, is it clear, Raz?
Yes, it is clear.
Mm-hmm. So it is available onto the local, and this is what is happening in the Hadoop world. Like the program is moving onto the Hadoop side, and the calculation will happen, and it will be happening onto the data which is stored inside the SDFS. At this moment, what we were doing, like we were having the program, we were having the jar file. Jar file is nothing but a packaged program. Okay, this package program was available, but we are trying to do the execution of this particular package jar onto the data which is stored onto the local of this machine, not inside the hdfs. It was assuming that the data must be available within the hdfs only. The data must be available inside the hdfs, then only the execution will happen, huh? Right, so this is the mandatory
Means
stuff.
means even the jar is working with the home means local system. It is stored in the local system, so we can but still it will move the data from SDFS to SDFS.
Yes, so what is happening?
Within the SDFS.
Okay, so what is happening over here? You are sitting onto the local, huh? And this is HDFS. Okay, HDFS. Huh? So you are firing, you are you are having the jar file over here with you onto the local, and you are firing it onto the data which is stored on the HDFS. Right, right.
Right.
Okay, so that is the stuff that you need to think. Huh? Although like these are not you can say mandatory stuff, but yes, as we have started a new journey, so we must have the understanding about these particular things, huh? So previously what we have seen like how to do the execution with the help of eclipse id, and now what we have seen how to package the code in jar file, and then do the execution with the help of that particular jar onto the data which is stored inside the SDFS, and storing the outcome on SDFS itself. Then we will, if you want to get this particular outcome, you can utilize the get command, and you will be able to move this particular outcome or result onto the local side of your machine. Right?
Right.
Naresh, Akhil, Rahul,
Yes,
Rohit,
sir.
Kesh, is
Yes.
it fine?
Yes, sir.
Yes.
Okay, okay, perfect, guys. Now, like, let's proceed with certain quizzes, and I'm going to share. Like, I want to make it more interactive. First, I was trying to have a Google form, but once we will be having Google form, so it will not be more interactive. So I want to make it more interactive. That's why, like, I have captured all the quizzes over here. Or just try to go through with the question, and these are the multiple choice questions, and you need to tell me the correct answer, huh? These are very simple one. You are having the idea, and you will be able to answer it definitely, huh? So which of the following statement about sdfs and mapreduce is true? SDFS is a programming language, while mapreduce is the distributed storage framework or system. SDFS is distributed storage, while MapReduce is a programming model for processing large dataset. HDFS and MapReduce both are programming languages used for big data processing. HDFS and MapReduce are both distributed storage system for managing large dataset. Which one is the correct? And I want the participation from all of you guys. Try to be more interactive, try to go through with the question, and tell me the correct answer, and
I
don't think
think
like,
D is the correct.
I
Sir,
think
I
D.
think
D
D
is
is the correct option.
okay, one is saying D and one is saying B.
the
B
B
for
option.
Bombay.
Yes, sir. B option.
I B.
B, huh? B for Bombay,
Yes,
right?
sir.
Yes,
Yeah.
sir.
Okay, okay, so why B is the correct answer? Why B is the correct answer? Naresh, can you try? Why B is the correct answer?
Sir, HDFS is actually storage system, and MapReduce we are using for data processing. That's why it's B is the right answer.
Hmm, that is perfect. So, guys, we know it very well that Hadoop is having two main component. First one is HDFS, and second one is the MapReduce. So, HDFS is the distributed storage, and MapReduce is distributed processing. And for the processing perspective, what we have seen, mapper, reducer, okay, combiner, partitioner. So what are those particular things? These are nothing but programming models, okay, how we can process huge amount of data. Okay, so B is the correct answer for this. Now, Hadoop is a framework that works with variety of related tools. Common cohorts include MapReduce, Hive, HBase, MapReduce, MySQL, Google Apps, MapReduce, Hammer, and Laguana. Then D is MapReduce, Huron, and Trumpet.
A, sir.
A, okay, one is saying A,
Yes, sir. A.
okay. And tell me like this, Raj, and answer is A. Say Naresh, answer is A. Akhil, say answer is B. Try to so that I will be able to pronounce, right? I will be able to pronounce your name. So I got the input from two persons. Rahul, which one is the correct answer? Or which
A.
one is answer from your side? A, okay. A. Rohit,
Yes, sir. Raj. A. It's A.
A. Okay. Can someone explain why A is the correct answer?
The same is here. MapReduce and Hive and HBase are tools that are used for data processing.
HBase for data processing,
Yes, sir. Hive also.
Okay. So, friends, like we have gone through with the ecosystem of Hadoop, and inside the ecosystem, we have seen these particular components: MapReduce, Hive, HBase. So, A is the correct answer. MapReduce, that is the processing framework. Hive is data analytics. With the help of Hive, we will be able to perform the data analysis. So, data analytics can be done with the help of Hive. And HBase is NoSQL database. So, why we need to have NoSQL databases? Because if something is stored inside HDFS, then in order to query onto the data which is stored inside the HDFS, we need to have a particular database. So HBase is NoSQL database that is providing the the result of a query with low latency, okay, onto the data which is stored inside HDFS. So for querying perspective onto the data which is stored inside HDFS, we need to have HBase, and these are the components from the Hadoop ecosystem itself. So that's why like A is the correct answer. Then next question is Dash as a general purpose computing model and runtime system for distributed data analytics. Which one is general purpose computing model and runtime for Distributed data analytics. Let me give you a hint. General purpose computing or general purpose processing, both are the same things.
The B drill, Akhil.
Be drill, huh?
Yes, sir.
Sir,
Okay,
it's Naresh sir A again, sir.
okay. Naresh A, I got the answer from two.
A map reduce Raj.
Okay,
Sir,
map
map
produce.
reducer. It's Kishan.
Okay, yes, Kishan produce, huh? So, I think Akhil said B, drill, huh? Apache drill. Akhil,
Yes, sir.
you said drill, huh?
Yes, sir.
So why drill? Why Apache drill? Or it was just a guess only, huh? Akhil, do you have the knowledge about Apache drill, or it was just a guess, huh?
So, sir, the Apache drill is a general purpose computing model and runtime system for distributed
Mm-hmm.
data analytics. So I have guessed drill for the same.
Yes, for the analytics perspective, that is fine, but that is not a computing model, right? You will be able to maintain schema and all with the help of Apache drill, but that is not a computing model, that is not a processing framework. It is something like we were having Hive. Okay, so Hive is able to do the data, you can say, analytics, and with the help of, we will be able to query onto the data which is stored inside HDFS. Okay, same thing you can do with the help of drill, but that is not a processing framework. That is nothing but MapReduce. Okay, so MapReduce is the correct one, huh? Now, next one is a dash serve as the master, and there is only one name node per cluster. Which one is serving as a master?
Name node B sir. B Naresh B sir.
Name node.
Okay,
Yes.
Naresh.
Name
Okay,
node.
name node.
B sir, name node.
That is the simplest one, huh? Name node. Yes, name node is the correct answer. This is the master of Hadoop ecosystem, and like it is used to maintain metadata, and metadata is nothing but data about data, like which block is moving to which data node. That is the job of this particular name node, huh? And all the all the data nodes are sharing the heartbeat message to the name node that they are alive, they are in the system only. So name node is the correct answer, and data nodes are the slave, huh? Moving further, you just need to point out the correct statement, huh? Data node is the slave worker node and hosts the user data in terms of data block, in the form of data block. Each incoming file is broken into the 32 MB by default, and data blocks are replicated across different nodes in the cluster to ensure a low degree of fault tolerance, and none of the mentioned. Which one is correct?
A sir. Naresh A sir.
I think A is only correct answer.
Mm-hmm.
Sir,
Data
Akhil
node
A.
is working as a slave
Mm-hmm.
and having the information of user data in the form of data blocks.
Mm-hmm. So 3% saying A. A is the correct one. Huh? What about others?
Sir, it's A and C.
Other B is not correct because size is not 32 MB.
C also, sir.
That's
C
correct.
also.
Huh?
And
So,
the C,
like say B
The C
and
also.
D, B and D, these are not like matching our choices, and these are the incorrect statement. But what about C? Data blocks are
on the
replicated
C,
across.
Yes, sir. A and C both are correct statement here.
A and C, sir.
So C is correct. Huh? Who is saying C? Naresh is saying C is correct, and what?
Yes.
Who?
Yes.
Naresh and Akhila. C.
Yes, sir. Yes. Yeah, yes. Yes.
So
No,
C is
sir.
correct. Huh? Okay,
C
no.
also correct, sir.
Akhila,
A
no.
and C both are. The race, sir. There is A and C.
But what do you mean by low degree of fault tolerance?
Fault,
If
sir.
you
Low
are
degree
If it
means
is if it
Yes,
is
sir.
high degree of tolerance, then it will be correct.
Yeah.
yes.
If it
So
is
if
high
you are
degree, then it is correct.
yes, if you are replicating blocks among different nodes, then there will be high degree of fault tolerance. Fault tolerance is nothing but say if one node is down or if one block is corrupted, then you will be able to recover that particular block. That is nothing but fault tolerance. Huh? If something mash is happened, okay, you will be able to recover that particular data. So that is high degree of fault tolerance. So C is incorrect one. Huh? A is the correct one, right?
Yes.
Okay. Moving further, dash name node is used when the primary name node goes down. This is the simplest one. Huh?
secondary name node is used.
Yes, sir.
Second
Uh,
reason. C. The race, C, sir. C.
Yes, sir.
uh, so this is the simple one. Huh?
Secondary,
Secondary name node
Yes.
secondary
is
C.
yes when the primary name node is down. Huh? Now put out the wrong statement. Huh? Replication factor can be configured at a cluster level. Default is set to 3 and it also set to a file level. Then block report from each node data node contains a list of all the blocks that are stored onto the data node. See, user data is stored onto the local file system of the data node, and D, data node is aware of the files to which the block stored on it belongs to. Which one is the wrong statement?
Or D. The race
I
D,
think
sir.
D is the wrong answer. Data node is not having the files information. I think it is regulated by the name node. Only
Mm-hmm.
that can
What
help
about
store.
others? What about others?
That is C.
D. Okay.
Sir, C.
C. Okay. User data is stored on the local file system of data node. Hmm. Okay. C. Who said C?
Sir, Akhil.
Akhil. Huh? Okay.
Because it is not stored on local file system.
try to focus on the line local file system of data nodes. Local file system of data node. So let me show you this particular diagram. This is Hadoop cluster. We are having master and slave over here. So data is stored where? This is not
in
onto
the
the
Hadoop,
user side,
in,
inside the Hadoop only, na?
inside the Hadoop only.
Right, Akhil?
Yes, sir.
Okay, so D will be the correct answer. Data node is aware of the files to which the block stored on it belongs to. So data node is not having awareness. So this is the incorrect statement. Now the next question, which of the following scenario may not be good fit for SDFS? SDFS is not suitable for scenario requiring multiple simultaneous write to the same file. SDFS is suitable for storing data related to application requiring low latency data access, and none of them mentioned above. Which one is correct? So which one is not correct?
Sir, it's B, sir.
B is not correct. Huh?
Yes, sir.
Okay. So Naresh said B. Akhil, Rahul, Rohit, Kishan, Raz,
1 second, sir.
tricky, huh?
C. It should be
Not
C.
good fit for SDFS.
No.
Sir, C, I think.
Okay. Can you think like A can be the correct one?
Sir, A is the
Anybody?
correct one. A is the correct, but the question is saying not may not be good fit for SDFS. Statement is
Hmm.
correct, but this is not a good fit. Well, this is a good fit, so it cannot be taken as the answer.
So tell me one thing, like why you need to have Hadoop?
Uh, it cannot be work with the same file simultaneously.
So over here, what is he is going to ask? SDFS is not suitable for scenarios requiring multiple write or simultaneous write to the same file. So say like inside I'm taking an example from the banking system. So inside the banking system, say what is happening, like inside the bank, say certain amount is there, and like there is gross, you can say, amount which is their gross total of a bank of a particular branch. Now some people have are going to deposit, some of the people are going to withdraw, and these particular things are being happening, and that is going to impact or you can say increment or decrement inside the overall gross, you can say, amount. So those are the you can say simultaneous values. Like some of the people are withdrawing, some of the people are, you can say, depositing. So these particular things are happening, and these are happening, you can say, throughout the world. Like say I can take an example. ICICI Bank is there, one branch is there, and that is having certain customers. So those particular persons are performing the or transacting the money. So at this point of time, like once multiple small transactions are being happening, then for that particular stuff, Hadoop is not a good solution. For that, we need to have database related stuff. Like Hadoop is meant for, like, we are having huge amount of data, and there will not be multiple write stuff. Like the file must not be updated again and again, like simultaneously updation, or it is not like that we need to you can say update the files again and again and then do the calculation. So Hadoop is not meant for that particular perspective. We will be going through those particular things as well, but Hadoop is meant like we are having huge amount of the data, and we need to do the processing on to top of that particular data. So is the correct one over here, right?
Right, sir.
Anybody having any confusion?
Yes, A is the correct answer. Means correct statement. But question is saying may not be good fit for SDFS.
Yes, this is not good fit for uh, HDFS.
Okay, actually there is a multiple
Ashok, but
But
the
simultaneously
answer is
but
that
working.
SDF is not suitable. So this is correct statement, but is not matching with the question
answer
statement.
it cannot be taken as an answer. I am saying because there
Actually,
is added or not.
the thing is that may not be good fit. May not be good fit. It is not like, it is not saying, say it is uh, not fitted for SDFS. Although like we can do these particular operations, right? Although we
Right.
can do such type of operations, but this is not best fit. We can do these particular operations. We can do the updation and all, but latency will be very high at that moment. So these particular things, it is saying like not suitable, not suitable, and these are not best fit for SDFS. These particular, try to complete it in this particular sentence in one line. SDFS is not suitable, okay, for scenarios requiring multiple or simultaneously writes to the same files, and these are not good fit for SDFS.
Yes. In this term we can connect the question and answer simultaneously. Then it will complete the statement. But as an answer, I think uh, it should be may be a good fit for SDFS. Which of the following scenario may be a good fit for SDFS? Means
And
below
try to go
below
through.
which statement is good fit for SDFS. So first one A is the good fit for SDFS means A is the correct answer.
Hmm. So A is correct. That's what I'm saying. And B, like SDFS is suitable for storing data related to application requiring low latency data access. Okay, so that's what we can do with the help of, and that's why like we can have SDFS, because like it is meant for processing huge amount of the data and providing the outcome with low latency, right? Where the monolithic machines were not able to, you can say, handle that particular data properly, and it is being handled by SDFS in a, you can say, good way. So that is like what is happening in the Hadoop world. So we can't say that this is not a, you can say, good fit. Huh?
Okay.
Okay. So try
Okay.
to
Okay.
complete over. Try to just Rohit. Try to complete the sentence and add this line at the end. Like SDFS is not suitable for scenario requiring multiple writes to the same file are not, you can say, good fit for SDFS or not a good fit for SDFS. Or you can, like, once we do multiple writes to the same file, that is not good fit for SDFS.
Yeah, it sounds good with the question. When we are adding the questions, it sounds good. Okay.
Okay, right? Rohit, is
Yeah,
it clear?
yeah.
Okay, okay, perfect. And what about others? Are you able to understand? This is a little bit tricky, huh?
Just only
Yes,
a
sir.
confusion statement only.
Might be, huh? So A is the correct one over here. Huh? Naresh,
Yes, sir.
Kishan,
Yes, sir.
okay. Then moving further, the need for data replication can arise in various scenarios like when we need to have replication factor. Replication factor is changed, data node goes down, data block get corrupted, or all of the mention above. Huh? Hmm. Which one is the correct?
Sir, sir, it's B, sir.
Speak loudly. Which one?
B,
B or
B, sir.
D?
B, 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 B.
Okay. Data node goes down. B. Okay. Akhil, Kishan, Raz, Rohit, Rahul.
I think all of them mentioned.
Okay.
Yeah, sir.
So,
D. All of the mentioned.
Yes, sir. All of the mentions.
hmm. So D is the correct one, friends. Huh? Why D is the correct one? I think Naresh answered B. Uh, replication factor is meant to provide fault tolerance. Huh? Like if a particular data node is down or a file is corrupted or a block is corrupted, and the block can be corrupted because of certain regions, like say during the transmission of data, like once it is transferred over the network, certain blocks may be corrupted. So if a block is corrupted, then how we will be able to recover it? With the help of replication factor only. So
Yes.
replication need will arise when the block is corrupted, when replication factor is changed, huh? Like say earlier replication factor was 2 and I'm willing to change it to 3. So then data replication will come into the picture because I'm going to increase the replicas of a particular block or file. Okay, and it can be onto the different level, like system level or file level. Okay, you can set it at different levels. Huh? So all of the above is all of the mention is the correct one. Huh? Then moving further, is the slave node and holds the user data in the form of data blocks. No?
Sir, repeat हो गया question ये.
Okay,
Data
sorry.
note.
Okay. Then SDFS is implemented in Dash programming language. Huh? Very
B,
simple.
The
sir.
Java.
B, 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 B.
Yeah, yeah,
Java
that is
B.
the simplest one. Java. And we have seen the Java programs as well. Huh? For yarn, the dash manager UI provides host and port information.
Resource manager.
Resource
Source
manager
manager.
UI provides the host and port.
Mm-hmm. Perfect. Huh? Yarn is acting as a resource manager for the Hadoop cluster. So C is the correct one. Huh? Then next question, during startup, the dash loads the file system state from the FS image and the edit log file.
Name node.
Mm-hmm.
Name,
Name
yeah,
node.
name node, yes.
Okay,
DC.
Akhil and Naresh, name node. What about others? What about others?
Uh, 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 I think it should be none of mention because secondary name node loads the file system state from FS image and edits log.
Mm-hmm. Okay, none of the mention. What about others? Okay, so I think Akhil told none of the mention, right?
Yeah, Raj called
No,
second.
Raj,
Okay.
Raj. Okay, so Raj, D is the incorrect one. B is the correct one. Basically, what is happening? Uh, like I have gone through with the FS image and that edit log file session, and where I have quoted the example of cricket match as well. Okay, so it is the duty of name node to put the files inside the shared memory and share it with secondary name node as well. Okay, it is the
Okay.
master who is like holding those responsibility to share those particular files which are having the system, you can say, image. Huh? System image means, say, like what is being happening inside the cluster. So that is shared in terms of FS image and edit log file, and these files are, you can say, keep on updating with the help of checkpointing. Huh? Then next one is point out the correct statement. Hadoop do not need specialized hardware to process the data. Then B is Hadoop 2.0 allows live stream processing of real-time data. Then C is, in the Hadoop programming framework, output files are divided into lines or records. Then D is none of the mention. Huh? Which one is correct? Huh?
C.
Okay. So in the Hadoop programming framework, output files are divided into lines or records. Do you
Sir,
really
B is
think
the
so?
correct.
B.
B for Bombay, Raj.
Okay. Raz said B. And
B
why
for
you were
Bombay.
saying? Yes, I got your input, Raz. I think Akhil told C, right? Akhil.
Yes, sir.
Okay. So why C came in your mind?
Because sir,
Mm-hmm.
it divided the data into a small chunks, sir.
But like it is not in terms of lines and records. Just try to think, Akhil. Records say, I'm having a structured data, and from a structured data, say like I'm having the employer data, and employer data, from the employer data, say employee ID 1, say Akhil, say department R&D, and say organization, say Microsoft. Then say employee ID 2, I can take say Rahul, who is working say with Google, employee ID 2, and the department is say sales. So one record is nothing but say like I'm fetching the value with respect to the employee ID 1. Say I want to fetch the data with top 50 employee. So that is nothing but 50 records. Are we having such type of, you can say, management inside SDFS? Have you seen? Let me try to correlate it with the outcome. So inside the outcome, just have a look. Say these are the output files. It, the, to, you. Okay. Do we have any, you can say, lines or number of records, or can I fetch like what is there onto the first number, first position, what is there onto the second position? Can I do that over here? Can I do that, Akhil?
So pardon, sir.
So you said you said in the Hadoop programming framework, output files are divided into lines or records, right? And I'm sharing the outcome. So we are having the output, say output 6 is there, and we are having files. So data is divided into files, that is perfectly fine with respect to Hadoop. But it is not divided in terms of lines and records, right? It is not divided in terms of lines and records. So we are not able to say age is like age 3 is this particular record. Data is there in terms of blocks, and we will be able to get block information. We will not be having information that is available in this particular block. Right?
Yes, sir.
Okay. So then which one is correct? Then which one is correct? Akhil.
But the Hadoop 2.0 allow live streams process for the real data, but it is also allowed to use not for the real data also. Na? It is not
Uh,
only for the live streaming processing data.
it is not only, or it can process.
It can process both, na sir, 2.0.
Yes. So uh, don't try to think in that way, like it is no, it is like processing this one only. If like some certain, you can say, application is able to handle live streams of the data, then definitely like uh, handling or processing the batch data, that is a peanut for this particular application, right?
Yes, sir.
However, like which one is being preferred, like batch processing is being preferred with the help of Hadoop. Hadoop is, you can say, running with certain latency related aspects. If we, you can say, compare it with the application which are, you can say, famous nowadays, say Spark and all. Spark is there, Flink is there, huh? So with, if we compare Hadoop with those application, then Hadoop is having a little bit more latency. But those applications which are providing better result, then those applications also can process the batch data as well, huh? Right? So it is not written in that perspective, say it is able to process line stream of the data. It will be able to process the batch data as well, huh?
Yes.
Okay. So
B is the
B
correct.
is the correct one, huh? Right? Agree?
Yeah, yeah, I agree.
And why A is not correct? Hadoop do need specialized hardware to process the data.
No, it is not requiring the specialized hardware because it is still the framework and having the different tools like uh, MapReduce and uh, two, three things, two components. So it is not having the specialized hardware for processing the data.
Hmm. So you can take an example like in our machine as itself, we have installed and we are running with one node cluster. Do we need to have any
Yes.
specialized hardware? No,
Yes, sir.
we are
We are
running with
running
the
No,
on
no,
the
no, not needed.
local machine. Yes.
commodity hardware, and we are able to, you can say, install it in our machine and we are able to execute it. So there is no need to have specialized hardware for the data processing with Hadoop.
Right.
Then, okay. So this one is the largest Hadoop cluster in the world. Which one? Can you think which one is the largest Hadoop cluster? Which can be the largest Hadoop cluster?
Sir,
I
I
think
think
Facebook,
C in the race. C, sir,
Hmm?
yes. C,
Facebook,
the
sir,
race of
Facebook.
C. I think, yes.
Hmm. C is the correct one because these organizations are having limited data, and well, if the data is more, then definitely the cluster size will be more. So Facebook is the
Yes.
correct answer. Okay, okay. So you can connect with me. So that's all with respect to the quiz part. Okay, so friends, we are going to start a new module that is distributed processing with Pyspark. Now, why we need to have Pyspark? Those particular things we are going to discuss. So, Hadoop definitely this particular module, which was available, which is available, still available. Uh, that is able to handle huge amount of data, and we are able to process the data as well. But Hadoop is limitation of Hadoop. I'm talking about limitation of Hadoop. So Hadoop is disk processing system. disk processing system. What is the meaning of disk processing? Say if I'm having certain things onto the disk, then in order to process it, I need to like take those particular things inside the memory, then do the processing over there, and then store the result inside the disk itself, huh? If like we are having chaining process, say like system 1, try to focus over here friends. System 1, system 2, system 3, system 4. I'm just giving an example why the Hadoop is having latency issues. System 7 and system 7. So what is being happening? Say I'm running with the chaining process, and system 1 input is given to system 2. Okay, and system 2 input is given to system 3. System 3 input is given to system 4, and system 4 processed data is given to as an input to the system 5. Okay, in the same fashion, like at the end I will be able to get the final output, final output. Okay, so over here, once this particular like over here we are having the input, we got the input, and I'm running with chaining process. I got certain input, and it is given to system 1. System 1 will process it, and then store the result inside the disk. Let me mention the stuff over here. Disk, 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 disk. Okay, final output, so system 1 is going to take the input, it is going to store it inside the disk. Okay, and once it need to process this particular input file, then it like took this particular file inside the memory, process it, and then store it onto the disk itself, input file is there, it will be moved onto the disk of this particular system. Then once you need to process it, it will came inside the memory, disk to memory. One processing is happened, then it is given to it is stored, the result is stored inside the disk, and then like that particular result is given to the system 2. It will be given inside the disk of the system 2. System 2, what it will do, it will, in order to process it, it will like took this particular input inside the memory, apply logic onto that particular data, process it, and then store it inside the disk itself, okay, and then give this particular outcome to the system 3, and then system 3 like move it inside the disk once the processing will happen, and then after processing the data will be moved onto the disk, and then it will be given to the system 4 as an input, and it will be stored onto the disk, the main thing is that once you need to process, the data will come inside the memory, and the result will be stored onto the disk. So this disk seeking time, disk seek time, disk seek time is more over here. Disk seek time is more in terms of Hadoop. Okay, so disk seek time is more, and because of this particular issue, these particular system, the Hadoop is having high latency. Okay, because the data processing is being happening, or we can say this, these are the disk processing systems, apart from this, like what is we are having, we are having Spark, Spark is in memory compute engine, compute engine, in memory compute engine. basically over here, these particular like middle step which was there in order to like move the result onto the disk, those particular things will be removed and the data will be stored inside the memory. If the system need to work, then it is going to take from the memory itself. If the system 3 need to work onto the data, or need to work onto the data which is given by system 2, so it is going to capture from the memory. So Spark is providing in memory computation, and because of this, Spark is more than, you can say, 100 times faster than Hadoop. Spark is 100 times faster than Hadoop, and like it is 10 times faster when once the processing is done onto the disk. Let me write it down. Spark is 100 times faster than Hadoop once the processing is done in memory, and it is 10 times faster once the processing is done on disk. So this is the first reason like why we need to have uh, Spark. Why we need to have Spark? So limitation is limitation of Hadoop. First one is the latency. Latency issue. So latency issue was there. Second thing, not a general system. Hadoop is not a general system. Is not a, you can say, general purpose. Or Hadoop is having different way of coding. Different components. Okay, so what is the meaning of this point number two? Like Hadoop is having different components. Like we are having Scoop, we are having Hive, okay, we are having Flume, we are having Pig, okay, we are having HBase, okay, we are having say Mahot, we are having Apache Storm. Okay, so different components are there inside the Hadoop. This is used for say data ingestion. This is used for Hive is used for data analytics. Data analytics. Analytics. Flume, data ingestion for streaming data. Streaming data. Pig again for data analysis. HBase, NoSQL database. Mahot, machine learning framework on top of Hadoop. Apache Storm, uh, streaming data processing. These are different tools in order to perform different tasks. Like if you want to do the ingestion of structured data, then you can have Scoop. But the main thing, like for each and every component inside the Hadoop ecosystem, we are having different way of coding. Scoop is having its own way of coding. Hive is having its own way of coding. Flume is having its own way of coding. Pig, its own way of coding. HBase is having, you can say, different coding. Mahot, like machine learning framework, which was developed by IIT and from you can say Kharagpur. So this is machine learning framework on to top of Hadoop. Apache Storm streaming data processing. Yes, different components are there and we are able to process our data. But all of these different components will be utilizing different way of coding. There is no, you can say, specific way of coding. That's why like this is a limitation inside the Hadoop, and we need to have something which is having more generalized view. Okay, and Spark is providing that you can say benefit, and it is saying just come to me, learn one way of coding, and and I will do better than the other tools. Okay, so this was again the limitation inside the Hadoop. Like person need to learn different languages. Say for the scoop perspective, like if that person need to perform the ingestion, he need to learn scoop. If like he need to work with Hive, then he need to learn SQL related stuff. Flume is following different way of, you can say, coding mechanism. Pig is having its own way of coding mechanism. So person will be, you can say, feeling tough once they are dealing with Hadoop ecosystem. There is no, you can say, single methodology. With the help of that, we will be able to, you can say, cover all of these particular things. Like if I want to perform the ingestion, then I need to use one way of coding. If I need to write down the machine learning stuff, then I can use that way of coding in order to apply the machine learning algorithms and all. So this is again the limitation, you can say, of Hadoop ecosystem, and we need to have something which is, you can say, have one way of coding, and I will be able to serve my purpose. I will be able to perform the task. First one is the latency related issue. Second one is the you can say the different way of coding issue. Then third one, like the issue, third challenge with Hadoop. Third challenge, third challenge like cloud and all. Okay, so with the help of this, like say, Hadoop is able to, you can say, with the help of Hadoop, what is happening? Say data is available inside HDFS, and then MapReduce is there, and then cluster manager is there. Okay, so it is taking the input from SDFS, processing it, and the cluster manager is going to manage it. But what is happening with the help of Spark? It is saying that give me the cluster manager of your choice. Cluster manager is Yarn over here. Yarn over here. Cluster manager Yarn over here. So give me the cluster manager of your choice. Give me the storage of your choice. So what is happening? So instead of SDFS, like I just need to replace this MapReduce with Spark, and what I need to do, like I can have S3, I can have local as a storage, I can have RDBMS, okay, I can have NoSQL database as a storage. So for Spark, it can be anything. S3 local, it might be, you can say, like say Azure Blob is there, okay, big Google BigQuery is there. So storage can be anything. You just need to have Spark, and you need to have a cluster manager, and it is not limited to Yarn. So it can be say Spark standalone alone and Mesos and Kate Kubernetes basically. Okay, so it can have any cluster manager, any storage, just we need to replace with, you can say, map reduce, and we will be able to perform the operation in a better way with low latency. And nowadays cloud is, you can say, is in demand. So this particular, you can say, methodology is not so much famous, and people are going to opt this particular methodology, like once like we are having cloud and all, we are utilizing Spark for processing with different, you can say, cluster managers and all. So this is the trending stuff, and that's why like certain challenges are there, and we are looking for Spark and all, and to process the data with low latency with, you can say, general purpose coding methodology, and we will be able to process the data. So these are the certain challenges. Because of that, like we need to focus in a direction that uh, we need to think for Spark, like we have started the stuff like distributed processing with Pyspark. So we need to have Spark for better latency and usage of cloud. And third one, like to have one way of coding. Because of these particular things, we need to have Spark. But Spark, just have a look onto this particular diagram. With respect to the Spark is like what I have mentioned. Spark can have different storage. Say local can be the storage for Spark, SDFS, S3, RDBMS, NoSQL database, whatever. You can use Spark once the data is stored onto these particular location. With respect to the cluster management part, you can have Yarn, you can have Mesos, Kubernetes, or standalone, Spark standalone. Then third one is the third component from the Spark side is Spark core. Over here, the data is the code is written in terms of RTDs. We will be covering that particular stuff. But at this point of time, just think like engine is there. That is nothing but the Spark core, where the code is written in terms of RTDs, resilient distributed data set. We are having different libraries: Spark SQL, MLlib, GraphX, streaming. So whatever you have seen, the operations which the Hadoop was able to perform, say hive was using SQL like language. So over here we are having Spark SQL. Inside Hadoop, Mahot is there for machine learning. Over here, MLlib is there, machine learning library. In order to handle the streaming data, Spark streaming is there. Inside Hadoop, we were having Apache Storm. Then to handle the graphical data, we are having GraphX, that is a library inside the Spark ecosystem. So different libraries are there in order to perform the task which was performed by Hadoop. But the main thing is that all of these particular task will be performed in one way of coding. There is no need to learn different, you can say, programming methodology in order to perform a task. Okay. Another, you can say, main reason, like why Spark is so much famous, it is providing different APIs like Scala, Python, R, and Java. So different programming APIs are there. These are the higher level languages. So If the pupil are having knowledge of Scala, then they can write down the code in Scala and they will be able to leverage the benefit of Spark. If they are having knowledge of Python, they can leverage Python API, that is nothing but Pyspark. Python plus Spark, that is Pyspark. If they need to, they are having knowledge of R, then they can leverage R programming API in order to work with Spark. If they are having knowledge of Java, they can write down the code in Java and that will be able to execute onto the Spark cluster. The main thing is that like in order to work with Spark, we need to have the knowledge of these languages. Okay, if we are having knowledge of any one of these languages, so we will be able to utilize the benefit of Spark. And that's why like Python is mandatory for data engineers. So we are going to opt Python because that is very simple as well. And Python, or we are going to utilize Pyspark API of this Spark in order to write down the code in Spark. And why we have used Spark? Because that is having low latency, one way of coding, and it is capable of working with the cloud related stuff. So that's why like we are moving with Spark related stuff. And why this is important for data engineers? Because like data engineers, for the data engineers, Spark is the mandatory stuff. And with the help of, you can say, Python, if we are having knowledge of Python, then we will be able to code for Pyspark. In terms of, you can say, Pyspark, we will be able to write down the code and we will be able to take the benefits from, you can say, Spark cluster. We will be able to process the data with low latency. So that is the thing why we need to go through with Python and why Python is mandatory, because we need to code for Spark. And Spark, for Spark, we are going to utilize the Pyspark API. And in order to learn Pyspark, we must have the knowledge of, you can say, Python. And what I am assuming that this particular, like we have started from the scratch, and like you guys are not having prior knowledge of Python. So Python basics will be covered in our sessions, and it will take 2 or 3 sessions in order to cover the Python basics. And once we will be having the Python knowledge, then we will deep down with the help of like Python knowledge into the, you can say, Spark world. So we will be learning Spark with Python. So let's move with the agenda, like Python for data engineers. I told you like why we need to have Python, because like we are going to write down the code in Pyspark, and for like write down the Pyspark code in efficient way, we need to have the basic knowledge of Python. Python is very huge, and it is, you can say, having lots of, you can say, application and all. But whatever is required for the data engineering perspective, those particular things we are going to cover from the Python. Then like module 2, that is nothing but the distributed processing. And like overview why Python for data engineers. I told you, I have described like why we need to have Python. And environment setup, I have given uh, the the playlist in order to perform the environment setup. Probably you have gone through with that, and we are going to write down the first program, and that will be the agenda for this particular session. So these are the, you can say, course modules that we are going to cover, okay, in our journey with Python for data engineers. And this is like an overview why, from where the Python came into the picture. So it is like functional programming as well as object oriented, having the methodology of OOP concept as well. Okay, and it was designed by Godiov and Rossum during 1985 to 1990. So it was like it came from this particular duration as a project, and then it is famous nowadays. Now, like, why it is so much famous? Because of its simplicity and readability. Like, if we are writing down certain things inside the Python, then that will be an English like language. And if we compare it with Java, Scala, or other programming language, where like we need to write down more code, and that will be in, you can say, less understandable format. So because of those particular reasons, like Python is so much famous in today's world. Then it can be used as a scripting language and can be compiled uh, to byte to the bytecode for building the large application. So over here, like, we can do the execution of Python code line by line. Okay, and we can bundle it in terms of, you can say, we can convert it in bytecode. Okay, source code to bytecode, and then it can be, you can say, deployed. We will be going through like same stuff that we have seen. Like, we were having a code inside the Eclipse ID, we bundle it and convert it into the bytecode, and we can share the bytecode to the another user, and that user will be able to execute that. So same thing we can do over here as well with the help of Python. This is high level, you can say, programming language, dynamic data types and store dynamic type checking and all. So what I told, high level programming language, and different data, it is supporting different data types and typecasting and all. We will be able to do it over here. Automatic garbage collection is nothing but, say, if you have a field, and if you have a field, and like you are you that field is, you can say, filled with garbage, huh? You are having a field, and that field is, you can say, filled with garbage. So garbage is nothing in the programming world. Like, if we have created certain functions, certain objects, and those objects are not used in that particular time. Okay, and they will become the garbage, huh? So that particular garbage need to be collected and need to be removed in order to have the better functionality. If like garbage is high, then definitely, like, we will not be able to perform the normal operations. So garbage collection is the automatic, which is happening over here. Okay, it can be easily integrated, like different languages are there. So this Python can be integrated with the different languages, and we are having a lot of libraries over here inside the Python, and we just need to import those particular libraries, and we will be able to perform our task. We will be going through with those particular libraries, say NumPy, Pandas, scikit-learn, okay, matplotlib, plotly. So different libraries we are going to utilize in our learning journey, and those, we just need to import, and we will be able to take the benefit. So Python is having another point, Python is having large community, and if you stuck somewhere, then you can pass your, you can say, issue or the error to the community, and you will be able to get the support. So large community support is there in the world of Python. Then learning ease and sport available, that is related to previous point only. It is, you can say, the writing is in English language, and large community is there. If you stuck somewhere, then you will be able to get the sport. Then user friendly data structure, that means like English like language, you will be able to visualize, you will be able to recognize the data structure easily. And Python is the beginner's language. Like, if you are not having any prior language knowledge, then just start with Python, and then you will be able to learn other programming languages as well. It is more easy to learn. The concepts are really very simple inside the Python. Then environment setup, like if you want to go with the PyCharm, then that is fine. I prefer to go with PyCharm, but if you want to go with Anaconda, then you can refer these particular steps. You need to go into the Anaconda, download it, and then run the installer. And just like you will be having certain instruction, proceed with the instructions, and then verify the installation, post installation. You just need to type the conda onto, say, anaconda prompt, and you just type conda version, and it is showing, say, conda 4.8.2. This is available inside my machine. So like I have installed it in my machine, it is available. And let me open, say, PyCharm ID. If you have gone through with the playlist, then you will be able to, you can say, have PyCharm in your machines. And PyCharm is the recommended, you can say, IDE. So try to go through with PyCharm. If you are good with, you can say, Jupyter notebook as well, then you can go with Anaconda. So let me type Anaconda and navigator. So once you have, you can say, downloaded this PyCharm ID, then you can create a new project over here. Just go into the file, then new project. Okay, give the project name, say, Python for engineering data engineers. Okay, this is the project there, and then everything is looking fine. Okay, new window. I want to have it in new window. So the new project is being created, and soon you will be able to see Anaconda as well. And over here, what you need to do, just click over here, Python for data engineers. Right click on it, and then new, and Python file is there. Give a name, say, test program. So I can say first program. Python file, first program. Okay, so first program, and let me try to mention, say, print welcome to big data world. And you just need to change it to the current file and try to run it. Okay, and you will be able to get the outcome, welcome to the big data world. So this is the way, like, how to create a project inside the PyCharm ID. And I will be referring this particular ID for the functionality. If you are good in, you can say, Anaconda or notebook, you can refer that as well. So inside the Anaconda, you are able to see the Jupyter notebook is there. Let me click onto the launch. and Jupyter notebook will be launched, and you will be able to write down the same code over there. Let me copy it. So just you can click over here, Python 3 file. Okay, new file will be opened over here, and type the same like print welcome to the big data world. You can change the name of this particular file like first program, rename. Okay, and just try to click over here and it will be executed. So welcome to big data world. So same thing like we have done over here, and if you are okay with Jupyter notebook, then you can go through with the Jupyter notebook. If you are good or you are like willing to have this PyCharm ID, then you can go with the PyCharm ID as well. I have shared a particular playlist with you all in order to set up the environment for Spark, and PyCharm is the part of that particular environment. Once you can say the Python is over, then we will be having focus onto the Spark itself, and that particular stuff will be you can say running over here as well. So we will run in order to do the execution of our Pyspark code. We will be utilizing PyCharm IDE. So that's it for this particular session. We have first we have you can say gone through with how to do the execution of how to do or how to export jar from Eclipse and perform the execution of files which are placed inside HDFS. This is the first topic. Then we have gone through with certain quiz, and I hope like it was interesting one. Quiz from big data and Hadoop for module 1. Then we have started why we need to have Python, overview of Spark architecture. Okay, what we have discussed, that is nothing but the Spark architecture. Then installation of Python, then creating a project, creation of a project in PyCharm IDE, and run first program in PyCharm and Jupyter Notebook. So that's all from my side, friends. If you are having any doubt, you can ask. Okay, these are the things what we have covered. In tomorrow's session, we will start with Python and proceed with data type, variables, functions, and different aspects what we need to have in order to get the understanding from Python. Anything that is in your mind that you want to discuss, Rahul, Rohit, Raj, Naresh?
Sir, in where you in YouTube where you telling about the environment setup about Python and Java. Both are installed. That's okay. But while installing Pyspark, getting some issue. It's not showing in system that is installed or not. But the process
Mhm.
step.
Okay. Spark, like you just need to place Spark in your machine, okay, and you need to set the environment variables. Huh? I will guide you, no need to worry. I will guide you.
Okay, sir.
Okay.
And sir, one more thing, sir. The last session video is also not in the lectures.
I have placed that
Previous.
video.
No,
No,
no.
no, I have placed that video.
It's previous session, sir. From today to previous session is video is not there, sir. Please check it.
Okay, last to last session. I will check. Huh?
Yes, sir.
I will check.
Yes,
Huh?
sir.
I will check. You can ping me onto that WhatsApp group if something is missing. I will be uploading it over there. Huh?
Okay,
I
sir.
think that video you will get on the playlist, YouTube playlist. You are saying week 2, day 5, right? Naresh,
Yeah, Raj, talking with me.
so that, yeah, yeah.
Yeah, tell
That
me.
is available on the YouTube playlist.
Okay, that is available in YouTube playlist, na? Environment setup or
Yes.
the last previous session video.
Only last session video.
Okay, okay.
It is available, friends. Those particular videos are not public with respect to Best 26, and the playlist for Spark environment setup, that is public. Huh? So you need to refer the link which we have shared for Best 26. So over there you will be able to see those particular videos. If you are going on to Boost Analytics, then you will not be able to see. Let me show you.
Yes,
Let me stop recording as well.